Scalar and vector products. A vector can be multiplied by another vector, but may not be divided by another vector. There are two types of vector multiplications used broadly in physics and engineering. The first is scalar product. The name scalar product emphasizes that the result is a scalar rather than a vector. The second is vector product. Vector product combines two vectors and producing another vector that is perpendicular to the plane of the original vectors. One example for vector quantity is force. Suppose an object is being pushed by a force. The force is a vector because it has a magnitude and direction, and the movement of the object is also a vector. This effect can be described mathematically as the product of the amount of force and the amount of displacement. This is simple to compute if the push is along the direction of the movement. But what if it is not? It turns out that only the amount of push that acts in the direction of the movement will affect the object's speed. This is an example of scalar product. Physical meaning of scalar product. The scalar product for vector A and B is the magnitude of vector A multiplied by the component of vector B parallel to vector A. Or we can also say that the scalar product of vector A and B is the magnitude of vector B multiplied by the component of vector A parallel to vector B. In short, scalar product involves the amount of one vector that is parallel to the other vector. We use this formula to compute scalar product. The dot product of vector A and B is equals to the magnitude of vector A times the magnitude of vector B and times cos theta, where theta is the angle between vector A and B. In order to get a maximum scalar product, we would want to make sure that the vectors are in parallel to each other, or of 0 degree, because cos 0 is equals to 1, whereas if the vectors are perpendicular to each other, we end up with 0 value. Torque is another example of vector quantity. Suppose we have a bolt and a spanner. In vector form, torque is the cross product of the radius vector and the force vector. If we push the spanner in the A direction, the bolt remains still. But if we push the spanner in the direction of B, the bolt will start rotating. Here, it is clear that vector product involves amount of a vector that is perpendicular to the other vector. Let's look at the physical meaning of vector product. The cross product of vector A and B is the magnitude of vector A multiplied by the component of vector B perpendicular to vector A. Or in another way, we can say that the cross product of vector A and B is the magnitude of vector B multiplied by the component of vector A perpendicular to vector B. So the keyword here is perpendicular. The formula for vector product is as shown. The cross product for vector A and B is equals to the magnitude of vector A times the magnitude of vector B times sine theta, where we know that theta is the angle between vector A and B. Different from scalar product, in order to get maximum product, the angle of the two vectors should be 90 degrees. When we cross vectors that are perpendicular, a new vector will form in a certain direction. But if they are parallel, we end up with 0 value because sine 0 is equals to 0. The direction of new vector is normal to the plane that contains vector A and B. The direction can be determined using the corkscrew method or the right-hand rule. Let's say we are doing A cross B. You need to position your hand that allows you to curl your fingers in the direction of A to B, and where your thumb is pointing is the direction of the new vector. Let's try another one. B cross A. Curl your fingers in the direction B to A, and your new vector is in downward direction. And that's the end of chapter 1. Thank you for watching.